Welcome back. This lecture is going to be mostly practice, figuring out meter signatures from notation and figuring out notation from meter signatures. Remember that the goal of notation is to show as clearly as possible where the meter beats are. In duple meters like 2-4, 4-4, and 2-2, and simple triple meters like 3-4, that means that note values in beaming should show quarter notes. In compound meters like 6-8 and 9-8, the note values and beaming should show dotted quarter notes. Here's an example of notation that doesn't show the meter beats. At a glance, we can't tell what the meter is. The dotted quarter and beamed eighth notes seem to indicate a compound meter with a meter level of dotted quarter notes. But that final quarter note ruins the clear meter. The fact that it has 8 eighth notes means that it can't be 6-8 or 9-8, but a musician sight reading this rhythm would stumble. Changing one beam connection clarifies the meter. Now at a glance we can see that the meter is 4-4. The red arrows show the quarter note meter beats. It sounds like this. Ba, 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 ba. Here's another rhythm that doesn't show the meter clearly. Is this 6-8? If so, these are the meter beats, dotted quarter notes, and this is the notation that most clearly shows it. So it sounds like this. Ba, 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 ba. If this is 3-4, these are the meter beats, and this is the notation that most clearly shows it. Ba, 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 ba. Remember that the musical accents determine the meter. I can show this with accents created by changing melodic direction. This is what this one sounds like. The melodic direction changes every 2 notes, creating accents every quarter note. As a result, this is the beaming that best shows the meter being created by the accents. The melodic accents caused by change of direction in this example suggest a grouping of eighth notes by 3. Which means that this is the best beaming and meter for this example. It clearly shows the dotted quarter note beats. Let's practice identifying the meter from notated music that is missing the meter signature. In the first example, the right hand makes it especially clear that it groups in pairs of eighth notes, so the meter beat is quarter notes. There are 4 of them in a measure, so it's probably 4-4. It could also be 2-2, but at a moderate tempo, 4-4 is probably more likely. Here, a C for common time is used instead of 4-4. In the left hand, you can see that 4 eighth notes are grouped together, which is very common in 4-4 or 2-4. Here's the right hand part. 1, 2, 3, 4. The middle example also has paired eighth notes, so a quarter note beat, but there are 3 quarter notes in the measure. This means that it's probably 3-4. The first measure is incomplete because it contains a pickup rest and note. Here's the right hand. 1, 2, 3. Finally, the bottom example has eighth notes that are grouped by 3s, so the beat is the dotted quarter note. There are 3 beats in a measure, each consisting of 3 eighth notes, so the meter is 9-8. This one also starts with a pickup note. 1, 2, 3. Here are a few more, this time from the Well-Tempered Clavier by Bach. Notice that the sharp key signatures in the middle and bottom examples have the first F sharp an octave lower than we expect. Key signatures in Bach's time didn't quite follow the same notation rules as they do now. The top example is pretty straightforward. 3 eighth notes in a measure grouped by 3s. The first measure is incomplete because it contains a pickup note. The meter is 3-8. It sounds like this. The middle example is a little less common. There are 4 groups of 3 16th notes, which means the bottom number of the meter signature will be 16 for 16th notes, and the top number will be 12 for the total number of 16th notes in a measure, and to show that it's compound, grouped in 4 groups of 3 with a meter of 12/16. The beat will be dotted eighth notes. 2 dotted eighth notes equals a dotted quarter note, and there are 4 dotted eighth notes in the measure. Sounds like this. 1, 2, 3, 4. The bottom one is a bit tricky. The eighth notes are grouped by 2s, but there are 12 of them in a measure. That might suggest 12/8, but then we'd expect to see eighth notes grouped into 3s, which isn't the case. What is being grouped into 3s here? Could it be quarter notes? The quarter notes are tied together in the second measure. Why not just use a half note? As I have been saying, the notation is supposed to show the meter beats. In this case, the meter beat must equal 3 quarter notes, or 1 dotted half note. The tied together quarter notes show the end of the first dotted half note beat and the beginning of the second beat. So this is a compound duple meter, 2 groups of 3 quarter notes, but it's not 6/8. Instead, the bottom number must be 4 to show that the quarter notes are grouped into 3s, and the top number will equal the number of quarter notes in a measure, or 6. So the meter is 6/4, and these are the meter beats. Remember the rule. If the top number is a multiple of 3, larger than 3, such as 6, 9, or 12, the meter will be compound with multiple groups of 3 in each measure. Now let's take a tune and figure out the notation and time signature based on the metric accents created by the music. Here it is in notation, without beaming or bar lines. At first sight, it's a little bewildering. There are no obvious patterns that give you a hint to the meter. But when you listen to it, I think you'll start to get a pretty clear sense of the meter. Try to tap along to the meter beat as you listen. Did you notice the pickup note at the very beginning? Because the second note is longer than the first note, it is more likely to be accented. The first note feels like it's taking off and landing on the second note. Accent. And then what? Is this a compound meter with a dotted quarter note beat? Probably not with a quarter note pickup note. Also, the accents created by the change of direction at the second eighth note suggests that a beat probably falls on the B flat. Accent instead of accent. And the half note F, being the longest note in the melody, is probably accented with a meter beat also. So the beat is probably quarter notes, with the second note as the start of the first complete measure. That's probably the beat you tapped to as you were listening. Here are the quarter note beats. This means that the eighth notes need to be grouped by 2s or 4s, but not by 3s. Now let's figure out how many beats there are in each measure. Are there 3, or 2, or 4? Listen again. Three quarter notes in each measure, that is 3/4, doesn't make sense. 3 1 2 3 1 2 3 1 2 3 1 2 doesn't fit. 2 or 4 fits the music much better. We can't really tell this by listening, but 4/4 is probably a better fit than 2/4. 4 1 2 3 4 1 2 3 4 1 2. So here's Jeannie with the light brown hair, correctly notated. The tune actually continues, of course. Instead of a rest at the end, there's another note that's like the pickup in the first measure. As I have been saying, notation needs to show the location and grouping of meter beats. Notation should also agree with the grouping of notes that are faster than the meter beats, usually eighth notes. The performer should be able to tell at a glance what the meter is and where the beats are. When determining meter, the best way is to listen and feel the meter beats, listen for triple levels, either as subdivisions or as groups of meter beats. So far, we have been assuming that musical accents caused by duration and melodic direction changes and so on agree with and reinforce the metric beats. But composers often write music that has accents that conflict with the meter beat. Composers also often write music that has a different beat subdivision than indicated by the meter, 3 instead of 2 or 2 instead of 3. In the next lectures, we'll look at such metric disagreement.